You can't do this with a blue diode laser, or this with a CO2 laser, and you definitely cannot do this with a fiber laser. This is a UV laser. Originally, I thought these were only good for plastics and glass. In today's video, we're getting a full picture of what you can actually do with the power of a UV laser. So let's talk about what a UV laser actually is and why it's different from a blue diode, CO2, or a fiber laser, which a lot of us have become familiar with already. The easiest way to understand UV is to think about the sun. You know, the sun that puts out ultraviolet rays, the same UV rays that give you a sunburn. A UV laser works in a very similar way. It's using an extremely short wavelength of light, ultraviolet light, and focusing it down to a tiny point. If you want a visual, think back to being a kid with a magnifying glass. You'd use it to focus sunlight onto a piece of wood or paper, and suddenly that light turns into heat right at that one spot. A UV laser is doing the same thing, but with way more control and at a microscopic level. Now here is where UV is different from other lasers. Blue diode and CO2 lasers mostly rely on heat to burn or vaporize material. Think of them like a very fine torch. Fiber lasers are incredibly powerful and great for metal, but they still rely heavily on heat also. A UV laser, on the other hand, is often called a cold laser, not because it doesn't generate heat at all, but because it uses so little heat that many materials don't burn, melt, or discolor the way they normally would. Instead of burning material away, UV light can actually break the surface at a molecular level. That's why it's so good at marking things like plastics, coated metals, glass, ceramics, and other delicate materials that traditional lasers would destroy. So when you hear 5 watts and think, that sounds small, just remember with UV, it's not about raw power. It's about wavelength, precision, and control. And once you see what this thing can mark cleanly, without scorching or melting, it starts to make a lot more sense why UV lasers are such a big deal right now. Alright, before we get too far ahead of ourselves, let's start with the unboxing. Or if that's not for you, just skip ahead to the next section. Honestly, Xtool is still showing how much they care about their machines, even with just the way they package them. This was a really good first impression right out of the gate. They actually thought about how you're going to get this thing out of the box. There are these 2 Velcro straps on the top that you can grab and pull up on, which makes lifting it out way easier. Now, quick disclaimer, this machine weighs just under 50 pounds, and for some reason, I decided the best move was to jump up onto my workbench to lift it out. Just a reminder, what I do here on YouTube is a how I do it, not a how you should do it channel. There's also a box inside labeled accessories. So once I carefully climb back down off the workbench, let's take a quick look at what's included.
All right, in the accessories pack, we have safety instructions booklet, quick start guide, power cable, USB-C, USB-A, or convert over to USB-C. I love these cables, those are great. A safety key, cleaning rag, a hex screwdriver, a right angle bracket, exhaust hose, the power adapter. Input is 100 to 240 volts. Output is 24 volts, 14.5 amps. The control screen. Materials pack. Inside the materials pack we have aluminum business cards, white paper, a piece of round glass, a sheet of 1/8 inch basswood, the cutting board.
Back to the machine itself. The first thing you notice is what I can only describe as the world's largest Ziploc bag. After sliding that off, there's another protective layer, and then you finally reveal the machine itself. And I've got to say, the design immediately stands out. The bright orange acrylic paired with the rose gold metal frame just looks striking. Even before powering it on, you can tell it doesn't feel cheap. Everything feels solid, well finished, and intentional. After removing the 2 pieces of securing tape, you pull the lid up and find a heavy metal shipping bracket bolted inside. You remove the 4 bolts, pull that out, and it's pretty clear why it's there. That bracket is doing some serious work keeping everything locked in place and properly calibrated, no matter how rough the shipping experience might have been.
Inside we have, I think this is the subsurface engraving lens. This comes with 2 lenses. One lens is probably already installed. More test materials. These are all pieces that you put together to create a platform for the subsurface engraving as well. A smaller screwdriver, some screws, a big piece of crystal which we can use for subsurface engraving.
Overall, first impressions matter, and right from the unboxing, it's already clear this machine was packaged and designed with care.
We have two different ports here for Xtool connections for accessories, like the conveyor or the rotary. Magnetic screen here, so you can get in there easily and clean up. We have the emergency stop button, connection for the computer. Everything's sealing up nice and tight, no air gaps on the bottom.
Once it's out of the box, setup is refreshingly straightforward. And honestly, that's something I don't take for granted with machines like this. First thing I do is attach the touchscreen controller, plug in the power cable, and run the USB-C cable to my computer just for the initial setup. From there, I hook up the exhaust hose. You can vent this out a window, but in my case, I'm connecting it to the Xtool AP2 air purifier so I can keep all my heated and cooled air inside the shop. With everything connected, I power the machine on and add it inside the free Xtool Studio software. It immediately prompts me to install the latest firmware, which only takes a few minutes. After that, you'll watch a short laser safety video, which honestly I think is a good thing, especially if you're new to lasers. Once setup is complete, I switch the machine over to Wi-Fi and ditch the USB cable entirely. From this point on, it's fully wireless. There's a quick calibration process, but I was happy to see my unit needed 0 manual adjustments. No tweaking, no loosening screws, it was already dialed in and ready to go. For the first project, Xtool walks you through a guided engraving provided on an aluminum business card. This is where a few key features really stand out. The built-in dual cameras, the LiDAR ranging system, and the autofocus. The machine knows exactly where your material is, locks in focus automatically, and shows you a live preview before it even fires the laser. This first engraving finishes fast. At this point, everything is set up, calibrated, and working exactly how it should. One of the things that genuinely impressed me the most with this machine is just how small it can engrave. And this is where UV really starts to show off. Using the same black metal business card from earlier, I engraved a QR code that's only 3 millimeters wide. To put that into perspective, the individual dots that make up the QR code are so small you can't even make them out with the human eye. And here's the crazy part. Even at that size, it still scans perfectly with my smartphone.
Check that out. It worked. That is a tiny code. Just the amount of detail you can get with this is pretty incredible.
That kind of result really comes down to one thing: spot size. The UV laser on the Xtool F2 Ultra UV has a spot size of about 1/100th of a millimeter. A human hair is roughly 7/100ths of a millimeter thick, so this laser spot is about 7 times thinner than a single hair. For comparison, a typical fiber laser spot is around 3/100ths of a millimeter. Most blue diode lasers are closer to 8 to 10/100ths of a millimeter, and CO2 lasers are bigger still, usually around 15 to 20/100ths of a millimeter. So when you hear that 1/100th of a millimeter number, just think microscopic detail. This thing can engrave lines thinner than what your eyes are used to seeing. That's why this QR code works. Not because it's powerful, but because it's accurate. I pushed it a bit further by engraving 3 separate lines of extremely small text on the same card. And again, without magnification, you honestly can't read it. You need a magnifying glass just to see what's there. This isn't about making something tiny for fun. This level of precision opens up the door to ultra-small branding, security marking, serial numbers, and QR codes where space is extremely limited, but accuracy actually matters. I imagine with text this tiny, I could probably take an entire book and engrave it on one of these aluminum business cards. Now let's talk materials, because this is where I was genuinely surprised. Going into this, I honestly thought this UV laser would mostly be good for plastics and glass. That's usually what people associate UV with. But once I started testing materials, it quickly went way beyond that. One of the biggest things that stood out across almost everything I tested was just how clean the results were. With a lot of blue diode and CO2 lasers, you expect some level of post-processing, sanding, cleaning off residue, dealing with burn marks or smoke staining, which can take a lot of time. With the UV laser, a lot of that just isn't there.
That's with no cleanup either. That's pretty cool.
I started with wood, specifically 3mm thick basswood, and it cut surprisingly well.
It can do 5, so 4 is actually probably the sweet spot. 4mm a second.
And the edges came out crisp with very little discoloration. I even cut out and assembled an entire Santa sleigh, and this really showed how tight the kerf was. All these parts snapped together cleanly without using any kerf offset setting at all, which tells you just how tight that cut line really is. From there, I tested a variety of other materials: cedar for a coaster, cork, slate, and several different colored acrylics. Clear acrylic wouldn't cut, which isn't a surprise. With a bit of trial and error, I was still able to get usable engravings on it, but you can tell clear acrylic is not really the best material for UV. We'll still have to give that to the king of acrylic, the CO2 lasers. I also ran tests on plastics, stainless steel, white ceramic tile, which does require some color filling and then wiping clean, but the results are quite incredible, as well as denim jeans, microfiber cloth, leather, and glass across the board. What impressed me most wasn't just that it worked, but how clean it worked. The lack of heavy burning, melting, or residue means less time finishing parts and more time actually making things. All these tests definitely changed my expectations of what a UV laser can actually do. It's a lot more versatile than I expected. Alright, now we're getting into what a lot of people are really here for: inner glass 3D engraving. This is one of those things that almost doesn't make sense until you actually see it happen. The laser isn't engraving on the glass, it's engraving inside the glass. To start, we're going to keep it simple and focus on standard flat glass pieces. This lets you clearly see how the UV laser interacts with the material and how precise the focal control really is. What's happening here is the laser is focusing at a specific depth inside the glass and creating tiny fracture points, layer by layer. Those points stack together to form a three-dimensional image that's suspended inside the glass itself. From the outside, the surface stays smooth. No etching, no texture, nothing you can feel. All of that detail lives completely inside the glass. Even with the flat pieces, the level of detail and depth is impressive, especially when you start layering shapes and images. And this is just the beginning. Once you understand how this works on flat glass, I'll show you the trick that makes it possible to engrave inside glass spheres, which takes this to a completely different level. Now, I want to share a few learning experiences I had while working with inner glass engraving, because this isn't just a click one button kind of process. When it comes to engraving inside glass, you generally have two main approaches: outline engravings, which is probably the easier one that I had the most success with, or fill engravings, which fills in the entire shape like a solid object. Outlines tend to be more forgiving and easier to dial in, especially when you're first getting started. Fill engravings, on the other hand, are much more demanding. They require a lot more laser activity in a very small area, and that can lead to heat building up inside the glass. In my case, I wasn't able to find a fill setting that I was actually happy with. As the engraving progressed, I could actually see heat building up inside the glass, and eventually the entire piece started to crack. Now, had I laid this piece of glass down flat and engraved it from a different angle, I probably would have had a more successful engraving, but I had it up like this for filming purposes. But you gotta imagine, as the laser passes through thick pieces of glass like this, it starts to lose power. So this long distance, overall, to get the very bottom of the jet engraved, I had the power set quite high. and as it got to the higher areas, that's where the heat started to build. Now, full transparency, I probably could have stopped the job as soon as I saw what was happening. But for science, I let it continue. I wanted to see how far it would go and what the final result would actually look like. And what this really showed me is just how sensitive inner glass engraving can be. You're working inside the material, not on the surface, and once the heat starts to build up, the glass just doesn't have many ways to relieve that stress. The takeaway here isn't that inner glass engraving doesn't work. It absolutely does. It's that settings, strategy, and patience matter a lot. Outline engravings are far more stable, and fill engravings require careful control to avoid heat-related issues. This was a good reminder that sometimes pushing a machine and letting a test fail teaches you more than a perfect result ever could. Another issue I ran into during inner glass engraving is that some glass, no matter what settings I tried, just would not engrave at all. After digging into it a bit, I found out that this often comes down to the type of glass itself.
Here's another one. It is not legit K9. You can see we got a tiny bit of the engraving there at the very, very end.
A lot of inner glass engraving relies on true K9 glass. And unfortunately, not everything being sold online is actually what it claims to be. I noticed this especially with some listings on Amazon. Even when the product description says K9 glass, the composition can be off just enough that it won't work for inner engraving. There's a really simple way to check this before you waste time or ruin test pieces. All you need is a UV flashlight. If you shine a UV light through the glass and the light passes through cleanly, that's a good sign. That glass is likely suitable for inner engravings. But if the glass absorbs the UV light and starts glowing intensely, that's a red flag. That type of glass isn't letting the UV light pass through properly, and it's not going to work for inner engraving, no matter what settings you use. My advice is to keep a UV flashlight handy. As soon as a shipment of glass arrives, test it right away. That way, if it's not usable, you can save yourself time, frustration, and money, and decide whether you've got some Amazon returns to deal with. I'll also try to keep a list of reputable sellers linked in the video description for anyone looking to buy legitimate K9 glass for inner engraving projects. Now let's talk about the secret behind inner glass engravings on spheres, because this is where things get really interesting. The main challenge with engraving inside a glass sphere is pretty simple. The laser needs a flat surface to pass through cleanly before it can focus inside the glass. A curved surface by itself just doesn't work. So the trick is creating that flat surface temporarily. To do this, I started by cutting a piece of black acrylic with a centered hole to keep the glass sphere perfectly centered. I also added several extra holes around it so air wouldn't get trapped underneath. That acrylic piece gets placed into a glass graduated cylinder. Then I carefully set the glass sphere into the center hole so it stays stable and level. Now this is where the magic happens. Xtool provided me with this clear liquid in a bottle with no description, but after a little research, I'm pretty confident it's just standard paraffin oil. The same type you can find at a local Walmart, often used for oil lamps. I slowly poured the liquid around the sphere until it just barely covered the top. That creates a perfectly flat liquid surface above the curved glass, which allows the laser to pass straight through and focus exactly where it needs to be inside the sphere. Once that's set up, I measured the height, entered the diameter of the sphere into the software, and positioned my STL files exactly where I wanted the engraving to appear inside the glass. The results were honestly incredible. One of my favorite was the light bulb design, because you can see the outer glass shape engraved and the internal filament and components suspended inside. When it works, it feels like science fiction, but once you understand the setup, it's actually a very repeatable process, and it opens up the doors to some seriously unique projects. I also wanted to spend a minute talking about the new Xtool RA3 Rotary, because this thing is extremely refined and way more versatile than I was expecting. Setup is quick, Everything feels solid, and the chuck style design makes it easy to hold a wide range of objects securely, especially things that don't sit well on roller style rotaries. I used the RA3 to engrave a few different designs on plastic cups, and it handled these without any issues at all. The rotation is smooth, consistent, and predictable, which is exactly what you want when working with detailed designs. I also did a full wrap engraving on a glass cup, and this is where things really highlight how precise a UV laser needs to be. With UV, focus is everything. It's incredibly important to make sure your rotary setup is perfectly level. Even a small tilt can shift the focal point enough to change how the laser interacts with the glass. On glass specifically, that focus difference can mean the engraving stays on the surface or suddenly drops just below the surface without you even intending it to. That's not necessarily a bad thing, but it's something you need to be aware of. The UV laser is so precise that small changes in height and focus make a big difference in that final result. Once everything is leveled and dialed in though, the RA3 performs exactly how you'd hope. It makes full wrap engravings clean, consistent, and repeatable. And it pairs really well with the level of detail a UV laser is capable of. This machine definitely surprised me in a lot of ways, and hopefully this video gave you a realistic look at what it can do, what it excels at, and some of the things you need to watch out for along the way. If you're interested in any of the tools, materials, or accessories I used in this video, I've got links down in the description below. I'll also try to keep a list of reputable sellers for things like K9 glass, since that can save you a lot of time and frustration. You'll also see some QR codes up on the screen. You can scan those to get to any of the resources I mentioned earlier as well. And if this video was helpful for you, you can help me out by clicking that like button, consider subscribing, or you can drop a comment below. I also enjoy reading your feedback, and if you've got questions or ideas for future tests, let me know. As always, I'm Chad from Chad's Custom Creations. Be encouraged, stay inspired, and keep on creating.